What? Yes, ma'am.
I wasn't here for the quiz.
That's so sad. You'll have to take it. No, you get a harder quiz.
Okay.
That's what happens. Okay, so who had a question? Kennedy?
Do you want me to read the exact question? Okay. A turtle on the ground is looking at a hawk in the top of a 64-foot tree. The turtle is 92 feet from the base of the tree. What is the turtle's angle of elevation?
Okay, so I tried to draw a picture as you were reading the question. Does that picture make sense?
Yeah.
Everything that you said?
Yeah.
Okay. So now I'm going to write an equation, and the equation is always going to be a sine, cosine, or tangent equation. This is my angle. I don't know it, but that's the angle in the problem. And here are the two sides. So which is this going to be, sine, cosine, or tangent? It's going to be tangent. So remember, this is some of you forgot, that when you write tangent, hooked to the tangent is the angle. You're not going to say tangent 64 or tangent 64 over 92. You're saying tangent x. Okay? And what does tangent x equal? Opposite over adjacent. So there's your equation. When it's tan x, when we are looking for an angle, what button do I have to press on my calculator? Second tangent. So second tangent, 64/90 seconds. Second tangent, 64/90 seconds. The answer should be, second tangent, 64/90 seconds. The answer should be 34.82 degrees, rounded to the nearest hundred. Okay, Kennedy?
Yeah, that's good.
Perfect. All right, anybody else? Quickly. All right, let's put those away. And then we're gonna get out our notes. We are really getting close, you guys, to finishing up. So be thinking about a test. If not at the end of next week, it will be the very beginning of the next week after that probably, okay? So here we go. Yesterday, or whatever day that was, we did some graphing. Remember? And we got the basic curves into our notes. So if you turn to the back of page 36, you should have drawn the sine, cosine, and tangent. Today what we're going to do is some more drawing, but we're going to modify those equations by putting numbers into them in different places. We're not going to make it too hard, but we are going to make some changes in our equation. Does anybody remember what this guy does? He multiplies the amplitude, and the amplitude is just a trigonometry word for height. So you look at your sine curve, your regular sine curve I had you draw. When you drew your regular sine curve, how did you label your y-axis? I said go up 1 and down 1. So the height of that curve is 1. The hills are up 1 and the valleys are down 1. That's called the amplitude. When you put a 2 out in front, now it makes the height 2. It makes the amplitude 2. It doesn't change anything else. So what were our labels here?
90, 180.
90, 180, 270, 360. They are not changing. A number out in front only changes the up and down, the vertical, the height. So now I'm going to draw my sine curve, but it is taller. Okay, so the amplitude is 2, the period is still 360. That part hasn't changed. The width of the picture is called its period. And that hasn't changed, because the number in front doesn't change that. Now, let's look at the next one. It's a cosine. There's a 3 out there, so we know what that's gonna do. That's gonna change my amplitude to 3, which means that my cosine picture is gonna go all the way up to 3 and all the way down to -3. We're on problem E now, right? Aren't we ready for E? Yep. Now, you know what your cosine looks like. Doesn't your cosine look like this? And our labels are 90, 180, 270, and 360. Remember, when you label your sines and cosines, you have to have a label for the high points, the low points, and where you cross the axis, the intercepts. And since we haven't changed it this way, it's still 90, 180, 270, 360. So my amplitude is, oh shoot, what did I forget? It's negative. Oh boy, what does that do? Yes, Ethan, it turns it upside down. So I'm very sorry about that. I can erase, I don't know what you can do, but I'm not gonna erase, I'm actually just gonna turn it over, and it's gonna look like this. Does that make sense to you? If I turn my cosine upside down, that instead of being, what did we call it yesterday, that skateboarding thing, or snowboarding thing, whatever you called it yesterday, instead of being that way, it's gonna be this way, if it's upside down. So that amplitude is 3, and the period is still 360. We have not changed the horizontal. Numbers out in front of the equation only change the vertical. Avery?
Is there like importance, like do you have to go through the 90 and the 270? Like why is that?
Because those are the x-intercepts. That's where the cosine is 0. So that's where you have to go through. Yep. Yep. And on the sine, you have to do 0, 180, and 360. Those points, yesterday when I had you graph the plane curves, those points are non-negotiable. Okay, so that's what we're gonna have every time. All right, now we have a negative tangent. Now, have I changed anything except the negative? Are there any numbers or anything in there? So my curve is going to be set up exactly the way your tangent curve was set up yesterday. So who remembers what that is, or look at it? What does it have?
Asymptotes at 90 and -90.
Asymptotes at negative 90 and 90. And a dot right there in the middle. And we're supposed to put in a squiggly line. And the normal squiggly line goes in like this, right?
Yeah.
But this is upside down, so isn't it gonna squiggle like this?
Yeah.
Amplitude and period. There is no amplitude. Amplitude is height. How high is this hill? Well, it's 3. Goes up 3. This kind of curve does not have height, so it has no amplitude. What's its period from beginning to end? 180. Yeah, that's different. This guy was 360.
So will we have to put the amplitude and period on a quiz or test?
Well, oh, I thought I had it on all these, but I guess I don't. Oh, yeah, it says list the period and amplitude
Okay.
for each.
Okay.
So yes, if it says that, that's what we have to do.
Okay.
All right, everybody still with me? What does the number out in front change? The number out in front here of the equation, what does that change? That changes your amplitude, right? Of course, if you're a tangent, it doesn't really matter because you don't have amplitude. All right, look at the next one. What's different about it? Now the number is not in front of the function itself. It's not out in front. Now it's on the x. That changes the period. That changes this way. This number right here, you might remember because we talked about it back in chapter 1, it divides the width, which is known as the period. That number is a divider. Okay? So I want you to think about this for a second. Have I changed the height?
No.
So it's still 1 and negative 1. The normal, if I were graphing a normal sine curve, these would be 90, 180, 270, and 360, right? That would be the normal. But what's happening? They're getting divided by a half. So what happens if you divide all these numbers by a half? They change, and what do they become? Instead of this, I'm going to do it in a different color. This label would be what?
45.
Oh no, be careful. 90 divided by a half is 90 times 2 over 1, isn't it? So that first label is 180. And the second label would be 360. And the next one would be 540. And the last one, 720. So now you got a curve that starts at 0 but doesn't end until 720. So his amplitude is 1, but his period is 720 degrees. Period's where you end. All right. Everybody still with me, okay? Well, now we have another sine curve. Oh no, we already did that one. Now we have a cosine curve. Cosine 2x. No number out in front, right? Which means that my amplitude is still just 1. And it's a cosine. So I know it looks like that, like one of those skateboard things. And I have to label where it ends, where it crosses, and where it bottoms out. Now what would those be normally? In a perfect world, what would those be? 90, I'll write them down here this time. 90, 180, 270, and 360. Those would be the normal labels, right? Now what has happened though?
Divided by 2.
I put a 2 in there, so it's divided by 2. So all of these numbers are divided by 2. Because that's what this number does. It divides the period. Or the width. So this label is now 45 and 90 and 135 and 180. So my amplitude is still 1, we didn't change that. How do you change amplitude? You put a number out here, right? We didn't, but I didn't change. And my period is now 180 degrees. So basically this picture's been shrunk. Okay, now we have a tangent. Now, I know, because you just told me a minute ago, that a tangent has an asymptote at negative 90 and an asymptote at positive 90, and squiggles through the origin. That's what a tangent curve does. Normally, that's a normal one. I probably should put these labels down here. This is the normal tangent. What's happened to this one now?
It's multiplied by 4.
It's been divided, these have been divided by a 4. Remember, this number right here divides the width, divides the period, and dividing by a 4th is the same as timesing by 4. So what is this label now? Negative 360, and this one is positive 360. Your period is start to finish, so be careful. This one starts at negative 360 and stops at positive 360. So what's its period? 720. Very good. There is no amplitude. Tangents never have amplitude, ever. But from negative 360 to positive 360 is a total of 720, isn't it? Oh no, look at Jay. There's a lot going on in Jay. All right, so tell me what's happening here. I have a sine curve that's been turned upside down. So when I sketch it in, it's going to start here and go down first, and then up. So there is a picture, would you agree, of a negative sine curve?
Yeah.
Perfect. Now, I need to put some labels in it. Okay? So tell me about my vertical labels. What are they going to be?
2 negative.
2 and negative 2. Now, normally, those labels are 1 and negative 1, but we times by 2. So now my amplitude is 2. Notice, amplitude is positive. Amplitude and period are always positive. What are these labels normally, right here? What are these? 90, 180, 270, and 360?
Yeah.
But those have changed also. How did they change? They've been divided by 1/3, which is the same as timesing by 3. So this one is actually 270. 90 times 3. You can use your calculator if you need to. This one will be 540. 810. 1080. Double check my arithmetic, is that right?
Yeah.
So our amplitude was 2. What's our period then? Distance from beginning to end is 1080. Okay, you're not going to get any harder than that, okay? That one's got not everything going on it. You're not going to get any harder. All right, what's the next one? 1/4 cosine 1/4 x. All right, it's the last one I'm doing. You're gonna work on the next one by yourself. Well, actually, maybe not. That's kind of a hard one. 1/4 cosine 1/4 x. Let's start by drawing the basic shape. It's a regular cosine, right? So that's your snowboard thing. How high is it? That's your height number.
4.
4? 1/4. This number multiplies. So it's 1/4 times 1. These are supposed to be 1. So it's 1/4 times 1. Your amplitude is 1/4. So in reality, shrunk. These are supposed to be 90, 180, 270, and 360. But what did we do? We divided them by a 4th. That number multiplies, this number divides. So dividing by a 4th is the same as timesing by 4. Ooh, these are gonna get big. 360, 720, 1080, and 1440. You can use your calculator. Or not, whatever you want. So my amplitude is 1/4 and my period is 1440. Now I was set you loose on this next one by yourself. And now that I think about it, I think maybe you can handle this just fine. Especially if you work with your partner. One quick comment though. See that 2 out in front? What is that 2 supposed to impact out in front?
The Y.
The y, or the amplitude, or the height, right? What do we know about tangents? They don't have that, so you're going to ignore that too. Okay, because it's a tangent problem. Now don't ignore it if it's a sine or a cosine, but because it's a tangent, we're going to ignore that. Because that number multiplies height, and tangents do not have height. They have an asymptote at -90 and +90, and a squiggly line through the origin. That's what tangents look like. So I'm ignoring the 2 because I don't have any height there. But what about that 1/5? That divides these labels by a 5th, which means timesing them by 5. So this would be -450 and +450. we have no amplitude, but we do have a period from negative 450 to positive 450 is negative 450 to positive 450, 900. Pretend you're a little man, this is a number line. To get from here to here, don't you have to take 450 steps? And then get from here to here, you take another 450, 900 steps. All right, 2 more of these to go, guys. Work on number M, or letter M. See what you can come up with for letter M. I want you to sketch it, label it, and give me amplitude and period. What are you doing?
I was looking outside.
Stop it. It said snowing. Right?
Yeah, it was getting cloudy around.
I don't know why you want it to snow and rain and sleet and all that crap, because that just means we have to zoom.
I wish we did it. I want to do that.
And the only thing worse than me in person is me on Zoom. All right, what have you drawn? I hope that you put an asymptote here and an asymptote here and a squiggly line through the origin. I hope that you mark these negative 90 and 90. But because the equation is tan 10x, what has to happen? Divide by 10. So the asymptotes are at negative 9 and positive 9, which makes the period beginning to end what? 18. And there is no amplitude. How many of you got that one right all by yourself? Oh, you were awesome human beings. Good job. All right, last graph. Then we're going to do something different today. Last graph. Here we go. We've got a sign. So what do I start with? I start with drawing my sine curve. The regular old sine curve has a hill and a valley, right? The amplitude is 1 and negative 1. And by the way, has that changed in this problem? No. So our amplitude is going to be 1. The only way to change your amplitude is to put a coefficient here. And we didn't. So our amplitude has not changed. These labels are supposed to be 90, 180, 270, and 360. Agreed? Every time. That's what a sine is, and a cosine. But what's happened? We've divided by 2/7. Okay, that's yucky. That's going to be 90 times 7/2. Might need your help on this one. That's going to be 315. Double check me.
Yeah, 315.
So 315. And they're all divided. So 630. 945 and 1260. I have no idea if those are right. I'm gonna let you double check me. Now, you probably noticed this, but I'll let you know a little secret. Mrs. Ford is not that good with arithmetic. I did not take 180 times 7/2, although I could have, that's not what I did. Instead, I noticed that this first little block was 315. So this one will be another 315 and another and another. So that's what I did. I just kept adding 315. You can do it either way, whatever you want, but that will always be the case, that these blocks here are equal. So once you know what the first one is, you can kind of just do that. So, amplitude is 1, and period is 1260 degrees, right? Easy peasy. What do we have to be sure we have memorized, you guys? The shapes. You gotta have the shapes memorized. If you have the shapes memorized, then making these changes isn't too bad, but you've gotta have those shapes learned. Alright, so 4-4, we just finished 4-4, so that homework, let's see, Tuesday, that'll be on Thursday. Remember, if we don't have real person school, you have to take a picture and email it to me. Okay? Alright, now we're starting 4-7. Mrs. Ford, what happened to 4-5 and 4-6? Well, we did part of 4-5 just now, and 4-6 we're not doing. So we're ready for 4-7. Alright? Alright, so everybody take a deep breath, because this is a totally different problem. We are not graphing. We'll draw a picture, but we're not graphing like we will here. This says no calculator. Find the exact value. Exact means no calculator. So I want you to think about this for a second. This problem says to me, find the angle whose sine is 1/2. So I'm going to draw a picture of a triangle and an angle here at the origin that has a sine of 1/2. Does that make sense to you? Does that angle have a sine of 1/2?
Yeah.
Remember, when we type this in on our calculator, aren't we finding an angle? Isn't that what this does? So that's what I'm doing. I'm trying to figure out what that angle is. Any guesses? Looking at those two numbers?
45? 30. No, 30.
It's 30. This is a 30, 60, 90 triangle, and across from the 1 is 30, right? So the answer to this question is 30 degrees. We're working it backwards. We know opposite and hypotenuse. We gotta figure out the angle. Ethan?
What is the negative exponent?
It's not an exponent. That is the inverse notation. That's on my calculator, second sign. Yeah. And anytime this notation is involved, you're finding an angle.
Whoa.
All right, next one. This says, find the angle whose cosine is √3/2. So here's my triangle, here's my angle. I want the cosine to be √3/2. So does this labeling look okay to you? Cosine? Adjacent over hypotenuse? If you're doing this without a calculator, that has to be special. That's a 1. Somebody said it's the same thing. Yes, indeed it is. It's 30 degrees. Now, let's not be like shocked at that. Every one of these you do without a calculator is going to be 30, 60, or 45, right? Because those are the only angles that we can deal with without a calculator. All right, C will be different. It's going to be a different angle. The tangent is √3. We're going to find the angle whose tangent is √3. And I'm going to write that as a fraction, √3/1. Because I remember that tangent is opposite over adjacent, so I like to have a fraction there. So I'm going to draw my triangle, and the opposite is √3, and the adjacent is 1. Now that would make the hypotenuse 2. Those are my special numbers, right? How big is that angle? 60. So the answer to the problem is 60 degrees.
How did you know to put the √3 on?
Remember, tangent is opposite over adjacent. So the opposite, this is always my angle here at the origin. Opposite has to be √3 and adjacent has to be 1. That's the definition of tangent. What's next? Now, this one I'm going to help you on. Okay, if I give you a negative, there are rules about the negatives. Now, as long as the number is positive, no problem. Draw it right there in quadrant 1, all is good. This triangle can't be drawn in quadrant 1. Do you understand that? Because there aren't any negatives in quadrant 1. So this triangle has to be drawn in a different quadrant. And on a test or a quiz, I will tell you which quadrant to draw, because I'm not going to expect you to memorize one more thing. They're called the principal values. And Kai, there's absolutely, the sign would be negative in quadrant 3, but it's also negative in quadrant 4, and that's the quadrant we use. So I will tell you that. I will put a little 4 over here to the side, and that will tell you to draw your triangle in quadrant 4. You do not need to memorize that. Now, as long as that number right there is positive, you're going to draw it in quadrant 1 and be fine. But if this number is negative, I'll tell you. So you're going to draw it in quadrant 4. This is your angle. The sine is opposite over hypotenuse. Does that make sense to everyone? Right? And that makes this one, and that makes that angle how big? That's a 1, 1, √2 triangle, which is what kind? 45, 45, 90. Kids, you got a sheet that's got that information on it. Look at it. This is a 45-degree angle. Now, please do not say that the answer is 45 though, because 45 would be up here. It's negative 45. Very good. Remember, negative angles go this way? So that's a negative 45-degree angle, because we came down. So the answer to the problem is negative 45. All right, I want you to try the next one by yourself or with your partner. And I'm going to tell you, I think it's another negative. So I'm going to tell you where to draw this one. Nope, they're all drawn in different places. That's what makes it so confusing. This is going to be drawn in quadrant 2.
Quadrant two.
If you were, wouldn't it, like, if you didn't give us the, like, quadrant, wouldn't it just be like the X over R, that's, like, figured out? Like, which
No,
quadrant?
because there are two places where the cosine is negative.
Okay.
X is negative in quadrant 2
Yeah.
and quadrant 3.
Okay,
So we have to narrow it down to 1. So you could definitely get,
close enough.
you could get the answer, but you'd also get another answer. All right, so I want you to draw a triangle in quadrant 2. For those of you that have forgotten where that is, you really need to know. This is quadrant 2. You're gonna label the sides so that the cosine is -1/2. And then try to figure out what the angle is using your colored sheet and your intelligence. Don't just sit there and stare into space. Try to figure it out, folks. Use that brain. You only have a few more minutes of school. Use your brain while you can. Okay, how did you label your sides? This is your angle right here. How did you label your sides?
2, 1.
2 here and -1 here? Because cosine is adjacent over hypotenuse, right? So that makes this a √3, which makes the angle a 60. Now, here comes the tricky part. 60 is not the answer. Because if you drew a 60-degree angle, wouldn't it work like this? The angle we need is this one. Remember, when we measure our angles, we start here. So we need to go all the way around to here. How big is that? All the way to here would be how big? 120. Gabe, how did you get 120? You're exactly right. That's the answer to the question. 60 from, yep. Gabe said, look, if we go all the way to here, it's 180. But we stopped 60 before we got there, so we only went 120. Stay with me, folks. Campbell?
Is it only like positive when it's on the top or?
Yep. When you're rotating this way, up and around, it's positive. When you're going down, which you're always going down when you're on quadrant 4. Every place else you're going to be positive. All right, here we go. I'm going to do another one. Quit yawning. This is exciting. The angle whose tangent is -1. It's a negative. I promise I tell you where to draw it. You draw this one in quadrant 4. So you're going to draw a triangle in quadrant 4. There's your angle. Opposite over adjacent. Remember, that's 1/1. -1/1. This would be a √2. And how big is our angle? 45. But we don't say 45, we say -45. Because we go down to draw that angle. -45. You starting to get the hang of it? All right, I want you to try G and H on your own. Kennedy,
How come we wouldn't try and find the angle like we did on the last one?
what do you mean?
Like how come we didn't,
So up and around, all the way
Yeah.
around like this?
yeah,
Okay, when we're in quadrant 4, we go down because it's shorter,
okay,
okay? If we're not in quadrant 4, we're gonna go up and around
okay.
when we're doing problems like this.
Which quadrant will H be in?
H is a negative cosine, so H will be in quadrant 2. H will be in quadrant 2. Where is G?
G is just quadrant
Quadrant 1 because it's positive. Remember, if they're positive, you draw them in quadrant 1. Only if they're negative.
Wait, what did you say?
What?
Yeah, they should.
H? What did you say?
Quadrant 2.
Alright, everybody should be working on G. I hear a bunch of talking and laughing. I think this is great fun too. But let's make sure we're staying focused. Ethan, you already got them both done?
No, I got the G done.
Okay, we'll do H.
Sorry, I forgot about H.
Cameron, you got them both done?
Because it's going that way, so you're like subtracting the 30. Like, yep, you got it, man. Tomorrow's everything on the back there,
I got 60 for problem G.
Yeah.
Did you get 60 for problem G? There's my picture. H is drawn in quadrant 2. I got 30 for H.
Wait.
Wait, no. I didn't get 30 for H. What did I get? 150. Absolutely. The answer to H is 150. Because your angle has to be measured in standard position, which means up and around. Now, I and J, and these are the last two I'm doing. Okay? We're gonna stop. I know you wish I'd keep going, but I'm gonna stop. But I need you to pay attention to it. I and J can't be drawn this way. Why not? What's wrong with I and J?
Zero.
They have zeros. And you cannot put a 0 on the side of a triangle, right? So if I can't draw a triangle, what do?
Draw a circle.
Draw a circle. So I'm going to go ahead and I'm going to draw my circle that has a radius of 1. So this is 1, 0, this is 0, 1, negative 1, 0, 0, negative 1. Don't you dare be confused. I plotted points. If I start at the origin and go this way 1, I'm at 1, 0. I went up 1, I went left 1, I went down 1. It's a circle whose radius is 1. Okay? Now remember, the first number in every pair is the x, and the second number in every pair is the 1. This is 0, this is 90, 180, 270. Now the question says, where is the tangent 0? Well, please start at the beginning. So the very first place your beady-little eyes need to look is right here. If that doesn't work, then you look up here. You see what I'm saying? Don't start over here. You start at the beginning at 0. This is 0 degrees. Now, in order for the tangent to be 0, that means y over x has to be 0. right?
So why is
Which means y has to be 0. Is y 0 right here?
yeah.
Yeah. So the answer to the problem is 0 degrees. Because if you put y over x, you get 0 over 1, which is 0. Now the next one says, I need the sign to be 0. Well, guess what? It's the same place. Because in order for the sign to be 0, don't we need y over r to be 0? And where is the first place y is 0? Right there. Nice work, guys. You got a few minutes to do homework? Please, no phones. No phones. We're using this time productively. Leave your phone here. Remember your 4-4 homework.